So, good afternoon. Thank you so much for taking the time to talk with us. I'd like to ask you just to introduce yourselves briefly and then let us know how it is that you came to be working together.
My name is Jill Gravanek. I'm a professor in the mechanical program, and I also am in the industrial program.
My name is Shreya Patki. I'm a third-year mechanical engineering student here, and I've been working with Dr. Bonnet for like the last 3 years, so it's been pretty fun.
So, is this your sixth semester of research, Shreya?
No, this is my fourth.
Your fourth semester in the Outstanding Scholars Program?
Yes, but before that I got a USRA, which was the Undergraduate Student Research Award, so technically I've been working with Dr. Bonnet before Outstanding Scholars.
Awesome.
Yes. That was the summer before I started, so the summer 2017.
Great.
Yeah.
And throughout that whole period, have you been working on this same project?
Yes.
Okay.
Yeah. So
Great.
it's been a continuation of that one project, so I've been working like piece by piece every single kind of study semester.
So what I think we'd like to know about is this award that you just won for the work that you've been doing, and then tell us the story of how you came to that place in the work.
I'd like to start.
Yeah.
I have my foot in many worlds.
Yeah.
And part of it is that we need to have an understanding of some mechanical engineering. We need the systems approach as part of the industrial engineering program. And we need to leverage some of these new tools that are being developed on a regular basis. And one of them is additive manufacturing or 3D printing. And this provides opportunities that just out and out couldn't have been realized before. And I'm interested in biomechanical research, and that requires obviously some sophisticated design and some sophisticated manufacturing. And guess what? It's been dialed back, some of the issues in the past, because of some of these new tools that have been introduced. And so I'm interested in a variety of different projects, and Shreya and I started discussing a modifiable hand brace, because people are in industry and they're trying to push little clips in, or they're at an awkward angle and they could get carpal tunnel syndrome. There could be problems with joint damage or arthritis. I mean, I think all of us know people that have arthritic issues, and there are, as the Ehlers-Danlos syndrome on top of that. So we all know people that could have a little bit of help. Anybody that's been involved in any sort of sport activity and have injured themselves or want a little bit of support. And the issue is, how can we customize it? How can we deal with different shapes, different sizes? And this is where the additive manufacturing comes in, because if you have a good model, it's not quite push a button and you're good to go. But it's as close as any process that's out there today. And this is where it gets interesting, because we need to have students that have no fear. And that's where Shreya comes in, because when she approached me about the NSERC, this is an NSERC award that she worked on in first year, I laid out a vision, and I gave her some advice about some tools that she could consider, and then she took and ran with it. So how do you eat an elephant one bite at a time? So Shreya has been slowly working her way through, and now it's time to segue to her, because this is the background, and the conclusion of it is that she submitted some work for a contest, a pan-Canadian contest, and she won.
Awesome.
Yeah, so for the past 2.5 years, I've been working with a software called Rhino. So Rhino is nice because it's in a way, because when in mechanical, we work a lot with CATIA, and CATIA is very heavy, and you need to in the fact that everything has to be very specific and very accurate in the way it does it, and certain tools, the flexibility you get with certain softwares like Rhino, you can't quite do that with CATIA. And because in Rhino, there's also a lot of cool add-ons like Bongo, which lets you do animation, and Grasshopper, which is the one I primarily worked with. So in Grasshopper, what I was able to do is basically take a bunch of different modules, so like a multiplication module, and then a module that creates a line, and put all these together, and I can actually make a finger that I can put in, let's just say, someone's hand length, someone's hand width, and because there's anthropometric relationships, which are basically relationships for the hand, relationships in general that relate the hand length and the hand breadth to the different finger sizes. So basically you can put in hand length, hand breadth into this model, and you can get out a finger model that kind of replicates what you, the measurements of the hand you just took.
When Shreya's talking about light and heavy, it's a mathematical definition is what she's talking about. That has more math, more precision that's required. And the models, CATIA, they can be parametric. They just can't be parametric as quickly.
So I'm a theater history scholar.
Okay, so they can vary. If I want
Parametric means,
if I want to go from one size to another,
yeah,
and all I want to do is say, I want to have the number 10, I want to have the number 20, you type that in somewhere, how quickly does that happen? With the software suite that Shreya's been working with, it's instantaneous.
Okay.
And when we have a demo, you'll be able to see that.
okay.
If she could do multiple things simultaneously, that would be challenging. It's not that CATIA isn't a very powerful tool, but for what we're trying to do, the Rhino lets you do a lot of exploration fast, quickly.
Great.
That was a cool part about it. So then kind of moving on from the actual hand, the model. So I have these fingers that I built, but basically the 5 fingers of the hand. And I was working away at kind of building, trying to like, create the actual hand model so that you can move everything just at once. And meanwhile, this competition came through that Bob and Dr. Ravana kind of brought up to me, and they're like, oh, there's this competition that does like, it's about additive manufacturing and 3D modeling, and then like, do you want to enter? And I'm like, sure. So then during my work term actually, so for January and February, I worked on getting manufacturing like a very primary kind of version of this hand brace that I would submit to this contest. And so I worked on, so we had a bunch of meetings in the beginning. So first was to decide what kind of design are we going for. There's multiple different designs you can actually do with the hand brace. You can have them either like the pillbow design, which is what I went with, or you can have something that just like almost like rings that go around. There's just so many different ways you can do it. We want to kind of like solidify like a basic design what we're going to go through. And then after that we have iterative meetings to go like, okay, this should be filleted, that you should maybe have like a jig underneath to help.
What does filleted mean?
Oh, filleted means if you have 2 edges and you want to like make them smooth, I guess is the best way to say it, you can have a fillet, so that just makes it kind of smooth and like a nice.
I see.
Better,
Okay.
because when you're wearing this on your finger, you don't want hard edges because you want
Right.
to scratch yourself, right?
Right.
So basically, fillets take over and make it smooth.
Okay.
That's all it was. So it's
I would do that with a router if I was using wood.
Yeah, exactly. That's exactly what you're doing. So you're
All
basically
right.
doing that, but digitally.
Okay.
So basically, we had meetings and we had to discuss all these different details, and then slowly I went through and kind of made these changes, and then email back and forth, and in the end we submitted, and then now I just learned a couple of weeks back that I actually won, which is
Well,
great.
warm congratulations to you both. It's very exciting. We feel very proud of you. I want you to know.
Advisor and guidance.
Right.
She did the work, and well earned.
But your work as a mentor
Oh, yeah.
goes back many years, even before your relationship with Shreya.
One of the things that I think it's very important for people to realize that just because we couldn't do it in the past doesn't mean that we can't do it now.